So this talk is called Mysteries of Speed Addition in Einstein's Relativity. I've looked at this issue for some time now about speed addition in special relativity, and it's messed up. Most things in Einstein's relativity are messed up. What I was collecting to say about speed addition was starting to get too complicated. Then I found someone who was dealing with it simpler, so going to deal with what he says. So this is the person who deals with it, and he's claiming that special relativity is wrong. And I should really point out that velocity is speed with a direction. So velocity is a vector and speed is a scalar, and the way I'm going to talk about it is I'm going to talk about it as a speed. So first of all, I need to point out that from my perspective, Einstein's relativity has been mistranslated and misunderstood. So there needs to be a revised relativity to what is commonly understood as relativity. And you can see, for instance, my 2023 talk, which I gave at ANPA. This is an alternative natural philosophy association conference. So I got a flip between what is commonly said about relativity and revised relativity, and that creates added complications. Anyway, trying to deal with what this person Jan says from commonly understood relativity, let's proceed. So Jan gives us this setup where you have two spaceships. First spaceship is going from the left to the right with speed c, and the second spaceship is going from the right to the left with speed c. And if they go on for long enough, they will crash into each other, but there should be a relative speed between them. And he gives the formula for what that relative speed should be. Saying from high school, that would be given by the following formula: u is equal to v plus w. But from special relativity, it gives a more complicated formula. And he says its two contradicting answers cannot both be correct. At least one of them has to be wrong! Exclamation mark. Now, I haven't found any decent literature from the mainstream dealing with this type of setup. What I've found from the mainstream is just a confusing mess. And what he's doing here is considering speed addition from Newtonian physics versus speed addition from special relativity for this given setup, when the spaceships have speed c. So looking at it a bit more closely, first off, mainstream would probably say this setup was not possible. They would probably claim that spaceships can't travel at light speed c. They would believe speed restricted to be less than c for material objects, while light is allowed speed c. So we'd probably have to be considering subatomic particles instead of spaceships moving at near light speed c. But anyway, proceeding with treating it as spaceships, although really should be treating it as subatomic particles, where you're considering the relative speed between subatomic particles. Let's carry on. So we have this following setup. We have a spaceship on the left going with speed v from the left to the right, and then we have a spaceship on the right going with speed w going from the right to the left. And we want to consider the relative speed between spaceships, and by Newtonian physics that is v plus w, and the relative speed is what a person on the spaceship on the left would say as the speed of the spaceship on the right was coming towards him as. And when v and w are much less than the speed of light c, so say for instance 0.1 c for v and w is probably allowed, then v plus w equals 0.2 c, and that would be approximately true. Well, for this situation where the spaceships are going at v equals w equals c, then the relative speed between spaceships by Newtonian physics would be 2c. So for a spaceship with speed v equals c and spaceship with speed w equals c, he gives relative speed from Newtonian physics as this equation u is equal to v plus w, and he says it's 2c. Now he's calling it Galilean transformation. Really he means just the usual Newtonian addition of speeds. Now what would the setup be according to special relativity? It would still have the spaceship on the left going with speed v and the spaceship on the right with speed w, but now it would add those speeds by this equation shown below. A different equation to shown previously, which would be the Newtonian equation for adding speeds. So now for special relativity with v equals w equals c, special relativity gives for the relative speed, when you substitute in v equals w equals c, that equation gives the relative speed as equal to c. Thus we have a conflict between Newton giving 2c for the relative speed and special relativity giving c as the relative speed. He concludes from this is Jian, he concludes two contradicting answers cannot both be correct. At least one of them has to be wrong! Exclamation mark. And he goes on to say this. He gives this box table where he lists all the possibilities, which is case 1, Galileo's formula would be wrong and Einstein's formula would be wrong. Case 2 would be Galileo's formula is correct and Einstein's formula is wrong. Case 3 would be Galileo's formula is wrong and Einstein's formula is correct, while case 4 would be Galileo's formula is correct and Einstein's formula is correct, and he considers this is the only possibilities. And but actually there are more possibilities than what is given here. But going with what he says for now, and assuming as he does that these are the only 4 possibilities. So what he says is case 4 is not possible because the 2 formulas contradict each other, while case 1 and 2 can be omitted as we're trying to prove that special relativity is wrong. If we assume special relativity is wrong, then no further discussion is needed, i.e. in case 1 and 2 you're just assuming Einstein's formula is wrong. So the only case you need to consider is case 3 as the only possibility, where you're saying Galileo's formula is wrong but Einstein's formula is correct. And that seems reasonable if assuming there are only these 4 possibilities. So he goes on to say this. So case 3 is the only possibility. Does that mean special relativity is correct? And he says no, because in the first equation of special relativity the Galilean transformation is used, or else the terms c minus v and c plus v would not appear, and that is an equation from Einstein's on the electrodynamics of moving bodies, his first paper on special relativity, and he's using normal addition of speed in that equation. He's saying c plus v, and that's a normal addition of speeds, i.e. Newtonian addition of speeds being used in that equation. And that is correct. It seems special relativity way of adding speeds is built from first assuming the Galileo stroke Newton way of adding speeds. So what you're saying is correct. It would be a disproof of special relativity if these 4 possibilities were the only possibilities. But these are not the only possibilities. It is supposed to be that by the mainstream the Einstein's formula at low speed approximates to Galileo's formula, and at high speeds the Galileo's formula is no longer valid. So we have to go through it all again. As per earlier, for this situation, relative speed between spaceships by Newtonian physics is v plus w, where v and w much less than the speed of light c, say the speed 0.1 c for v and w, that would probably be allowed, and then v plus w equals 0.1 c plus 0.1 c equals 0.2 c, and that would be approximately true. And now for what special relativity will give. From special relativity it would be using this equation for the relative speed, and you substitute the value of v equals w equals 0.1 c into that, and you get the value of 0.198 c approximately, while noting that earlier the Newtonian value for this relative speed was 0.2 c. Thus the special relativity value is approximately the same as the Newtonian value, and that's for low speeds. So for the low speed of v equals w equals 0.1 c, the way special relativity adds speeds gives approximately the same value as what the Newtonian way of adding speeds would give. So for the situation from special relativity, where it has this equation for relative speed between the two spaceships, that equation diverges more and more from what the Newtonian value would be for greater speeds. For this situation, thus for V and W as both value as C, if it were allowed, then the special relativity equation gives the answer of C, in which the Newtonian value for relative speed would be 2c, but that would be deemed false, and the actual value of relative speed was c, not 2c. So the Newtonian equation for relative speed is deemed good for low speeds, such as a low speed of 0.1 c, but if you go to very large speeds, such as a speed of c, then the Newtonian equation is no longer valid. And that's what the mainstream seems to believe upon this issue of relative speed. But it's still valid what he says about Einstein mixing together two different ways of adding speed. Special relativity from Einstein, and is the way the mainstream seems to believe it, is you build upon the idea of assuming the way Galileo / Newton add speeds, and then you try to form a different equation for adding speeds. And it is a contradiction to have two different ways of adding speed. Now, as I've dealt with in my previous videos, such as the talk I gave in 2023 at the ANPA conference, Einstein's relativity has been misunderstood, and it should really be the case that what you see is by Newton and what you measure is by Einstein. So the equation U plus V, which is the Newtonian relative speed, that is valid for all speeds as what we see. So it does give C plus V is equal to 2c. But when you measure, if you're doing it by the Einstein method, then it obeys that more complicated equation. That is obeyed for all measurement speed of speed. And the existing belief that the mainstream has for how it deals with Einstein's formula and Galileo's formula is just false. The C in these two equations is not the same thing. You have from Newton, U is equal to V plus W, and for Einstein's special relativity, for his relativistic speed addition, he has that more complicated equation. Now, U is not the same, so ideally you should put subscripts on it to show they are different things. So it'd be U subscript N for Newton, as being equal to V plus W, and that would be what you'd see as relative speed according to Newton. While for Einstein, when you do his measurements or his method, you have a relative speed of U subscript E, and so it's two different things. if you should not really be mixing these two equations. The u subscript n does not equal u subscript e, and that's how the mainstream have messed up their understanding of Einstein's relativity while dealing with relative speed. And so Joanne, who was dealing with relative speed in the context of relativity, almost had it right. He was right in pointing out that you should not be mixing two different ways of adding speed, but he didn't realize the false thing that the mainstream was saying about how you deal with the Newton or stroke Galilean way of dealing with speed versus the Einstein special relativity way of dealing with speed. And so that's the end of this little talk. Thank you.